Hey guys, so today we will be going through a Leetcode problem called maximum gap. Uh, so this problem is very easy if you are trying to solve without a linear time and without using linear extra space. But the problem arises when we follow this constraint that we must write an algorithm that runs in linear time, that means O1 time, and uses linear extra space, that means O1 space. So first I will go through a name based solution, and then let's switch to a more optimized approach, that's using a Radix sort. So first, for the name based approach is like we can initially sort the array using the sort built-in function, and then we can go through the iterate over it and solve it. Wait, first let's go through the question once also. Given an integer array nums, return the maximum difference between two successive elements in its sorted form. So to make this in sorted form, we sorted the array, and then to get the maximum difference between two successive elements, we traverse from 0th index to length minus 1 index, and uh, tracked the maximum difference in an answer variable using our and um, iteratively updating it if answer is less than nums current index plus 1 minus nums current index, then update the answer variable. So this is a pretty easy solution. So to try run this 3691, basically what we are doing is, so here 3691, here we have answer currently as 0, or we can assign as it as like negative as well, but negative is not possible because we are sorting the array. So if in sorted array, either the next element would be greater or equal to current element. So this equation nums I plus 1 minus nums I would never lead to negative, so we can go with initial minimum as 0. Then let's make this a little bigger. So first we are at index 0, 3, but before computing this we need to sort it, right? So after sorting this, it will become, first value would be 1, then 6, no, not 6, 3, then 6, then 9. Now we can try run over this loop. So here first we go to 0th index, so difference between 0 and 3, 0th index and first index, basically first index minus 0th index is 2, so it is greater than 0, so this will become 2. Then we move to 3rd index, we will compute 6 minus 3, which is 3, which is greater than 2. This will become 3. Then we go for second index. In second index we compute 9 minus 6, which is 3 again, which is same as this, so we will not reassign. So our maximum difference is 3. We are stopping here. To stop here, we will just iterate till the length minus 1 iteration. That's basic. Now this algorithm would take O n log n, because this part would take n log n complexity. So how can we make this in O n complexity? What we can do is that we can deploy Radix Sort. Radix Sort, it will take array and length of the array, and the complexity would become O of n. Now, two important things to keep your mind is that how Radix Sort works and when you should use it and when you should not use the Radix Sort. Okay, so Radix Sort. Radix Sort basically works on the principle of sorting digits at each digit places. So what is the basic key idea is like the key idea behind Radix Sort is to exploit the concept of place value. Sorry for the spelling mistake. And it assumes that sorting numbers digit by digit will eventually result in a fully sorted list. So what this actually means, I will go make you understand using an example. So let's take an array. Let's say it has 170, then 45, then 75, then 90, then 802, then 24 to 66. Now, as we all know, Radix Sort would sort the elements using each digit places values. We will be sorting this from least significant bit to more significant bit. So in case you don't know what is least significant bit and most significant bit, least significant bit of a number is the least value that is present at the ones place, or you can say, for this example 170, the least significant bit is 0, and most significant bit is the digit that is present in the leftmost part of a number. That is, for 170 it's 1. Okay. After knowing this and knowing this array, we need to deploy Radix Sort. How would we do that? So the first and most important step is to know the highest most significant bit. Why? Because we are traversing from the least significant bit to the most significant bit. We need to know from till which most significant bit we need to deploy sorting on each digits. So for the given example, we can find largest integer that is largest is 802. Okay, 802 whose most significant bit is at third place. Okay, now going to second step. What is the second step? We know what is the lowest LSB and till which most significant bit we need to sort. The next step is sorting itself for each of the significant places. So second step is sort elements based on unit place to the highest MSB. And which technique we will use? We can use any sorting algorithm, but we should use the algorithm that easily fits to this approach and yields least time complexity, and it's actually the counting sort. Sort using counting sort in O n complexity, time complexity. If you want to know more about this counting sort, there would be other videos also of my channel or other channels. You can go through that. This is only to understand Radix Sort. So let's start the Radix Sort. So first we need to sort the elements using unit place. This, 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 this. Alright. So and also this. So using Radix Sort, the resultant array would be looking something like this. We'll make the resulting array. So lowest number in listing in unit place is 0. So whoever at 0, 170, then 90, anything else? No. Next, do we have 1 at unit place? No. Do we have 2 at unit place? Yes. It's 802 and 2. Do we have 3 at unit place? No. Do we have 4 at unit place? Yes, 24. Do we have 5 at unit place? Yes, 45, 75, nothing else. Do we have 6 at unit place? Yes, 66. Do we have 7 at unit place? No. 8, no. 9, no. So this is after sorting using unit place. Then after this we have to sort using tens place. Keeping the positions at the correct places. So 10th place. We can consider 2 as 0, 2. Okay, for ease of understanding. 7 is 10th place. 9 is this 10th place. 0 is 10th place for this number. So on 0, 2, 4, 7, 6. Okay. Now let's sort this using tens place. So do we have 0? Yeah, we have 0. 1 is 802. Then we have 0, 2. Then we have no zeros. 1. No, we don't have 1 at tens place. 2. Yeah, we have 2 at tens place. Then 3. No, we don't have 3 at tens place. 4. Yeah, we have 4 at 10th place. Then 5. We don't have 5 at 10th place. 6. Yeah, we have 6 as 10th place. Then 7. Yeah, we have 7 at 10th place. And anyone else? 7, 75. Then 8. No, we don't have 8 at 10th place. 9. Yeah, we have 9 at 10th place. No else. Okay. Now the last iteration is the highest most significant bit, that is the 100th place. So we have to sort this array using the tens place. So sorting using hundreds place. Okay, so I'm just adding 0 0 for those who doesn't have anything in their 10th place. Actually we don't need to add this 0 in our algorithm. Okay, I'm just adding it for making you understand easily without any confusion or anything. Also we need to preserve, we are preserving the previous order as well while sorting. Okay, now do we have zeros at 100 plus? Yes, lot of them. So 0 0 2, then 0 24, then 0 45, then 0 66, then 0 75, then 0 90, then no more zeros. Do we have ones at 100 place? Yes, one element is there, that is 170. And then we have straight up 8 CO2. So this is the final sorted element, just removing the preceding MSP 0. So you see the sorting algorithm took this sorting algorithm took 4 1 2 3 into n time complexity, which is O n time complexity only, and it's linear, and we are just using linear space only, so that is also covered.